This video is an introduction to acids and bases. To start out, we're going to talk about something called pH. Now, pH exists on a scale. You've probably heard of this before. We have substances with low pH that are acidic, and we have substances with a higher pH that are basic, and substances with a pH of exactly 7 are considered neutral, so not basic or acidic. But what exactly is pH? Technically, pH is a measure of the concentration of hydronium ions in solution. But what are hydronium ions? When we talk about something in solution, we're talking about it in water. So here I have two water molecules. You can see the oxygen, hydrogen, hydrogen, oxygen, hydrogen, hydrogen. And they're just hanging out. But in liquid, molecules move. So what happens in water is that sometimes molecules actually bump into each other. And when they come apart, the hydrogen has stuck to the other oxygen. This is called a hydronium ion. Has a charge of +1. So pH is the concentration of hydronium ions in the solution. These square brackets around the ion mean concentration. Now, a lot of people talk about pH as a concentration of hydrogen ions, but hydrogen doesn't really exist just floating around in water by itself. It only really exists in this form, so we just talk about it as a hydronium ion, or the hydrogen attached to water. And just for your reference, you should recognize what this is from a polyatomic ion chart. That is a hydroxide ion. Oxygen and hydrogen with a -1 charge. When we're talking about pH, we're talking about a concentration, but we also know that pH is a number from 0 to 14. So how do we turn a concentration of ions into a number from 0 to 14? For that, we need to talk about how to calculate pH. So the concentration of hydronium ions is given as a ratio or a fraction, as the number of hydronium ions compared to the number of water molecules. So let's say for every 1 hydronium ion, there were 10 million water molecules. That still is not a number between 0 and 14, so here's what we do. We take this number and we put it into scientific notation, or we plug it into our calculator, and we get 1 times 10 to the -7, since we move our decimal place 7 times to get to 1, and I multiply that by -log, which is a button on our calculator. That gives me a pH of 7. So with this ratio of hydronium to water, we have a pH of 7. What if this was the ratio of hydronium to water? What would the pH be then? I would turn this number into my scientific notation, multiply it by -log, and I get a pH of 11. Now that we have a better understanding of what pH is, let's talk about acids and bases. So first, a quick note. Acids and bases only behave as such when they combine with water. If we had a powdered version or a dry version, we wouldn't get the same effects. So when we're talking about acids and bases, we're talking about them being dissolved in water. So acids have a pH of less than 7. Remember, this is because they have a higher ratio of hydronium ions to water molecules. Acids make the concentration of hydronium ions higher than the concentration of hydroxide ions. So remember, when two water molecules collided, they created 1 hydronium and 1 hydroxide ion. This solution is still neutral. It was just 2 water molecules. There's equal numbers of hydronium and hydroxide. If the number of hydronium ions goes up, this solution would be acidic. Let's look at acids in water. Let's say we're going to put this HCl, or hydrochloric acid, into this water. HCl is going to dissociate or break into its ions, and that hydrogen ion is going to link up with water to form hydronium. Now, even if more water molecules collide and hydroxide is formed, there's still going to be more hydronium than hydroxide, so this solution is now acidic. The pH would be less than 7. So this hydrochloric acid plus water gives us our chloride ion and our hydronium ion. What about bases? Bases have a pH greater than 7. This means that the substance has a lower number of hydronium ions, but in a more practical sense, we end up having more hydroxide ions than hydronium ions. Basically, with a neutral solution or substance, we have a pH of 7, and these two ions are equal. With something that's acidic, we have a pH that's less than 7, and the hydronium ions are more than the hydroxides. In a basic solution, it's the opposite. We have a pH that's greater than 7, and the hydroxide ions are greater than the hydronium ions. Bases make the concentration of hydroxide ions higher than the concentration of hydronium ions. So let's look at bases in water. If we put something like this sodium hydroxide in water, it's going to make the solution basic or have more hydroxide ions than hydronium ions. So when this goes in the water, we get a positive sodium ion and a negative hydroxide ion. Now, even if more water molecules collide and create hydronium and hydroxide, it's never going to balance out this extra hydroxide. Because every time two water molecules collide, a hydronium is created, but so is a hydroxide. So overall, this solution stays basic. So there's one type of reaction we didn't talk about in our types of reaction video. This is known as the neutralization reaction. The result of a neutralization reaction is that there is a neutral substance, or it has a pH of 7. In other words, the concentration of hydronium ions is the same as the concentration of hydroxide ions. So let's look at the reaction. In a neutralization reaction, an acid combines with a base, both of which are dissolved in water, and this creates a dissolved salt and water. When I say the word salt, I don't necessarily mean sodium chloride like table salt, although it could be. The term salt in chemistry just means a soluble ionic compound. Could be something like sodium chloride, but it could also be something like magnesium iodide or lithium bromide. Anything like that would be considered a salt. So if the acid and base are combined in the correct amounts, the hydronium and the hydroxide combine in equal ratios to cancel each other out and form water, which we know is neutral. So let's look at an example of this. Let's take hydrochloric acid and magnesium hydroxide. We know it's aqueous, so we're going to dissolve these compounds in water. And using what we know about neutralization reactions, we know we're going to have a salt and a water. So this is going to be a double displacement reaction where we have magnesium chloride and water as our products. Now we have to balance our equation. I see there's 2 chlorides, so I have to have a 2 here. On this side of the equation now we have 4 hydrogens, 2 oxygens, so I also have to double my water here. Now let's see what that looks like. First I have to double my hydrochloric acid since I have 2 here, and now I can put it in the water. Now once these substances go into the water, they're going to dissociate into their ions. So we have some positive hydrogen ions and negative chloride ions. Got some negative hydroxide ions and a positive magnesium ion. Now what's going to happen is the positive hydrogen ions are going to be attracted to the negative hydroxide ions, and they're going to join together to form water. The magnesium and chloride ions are going to stay floating around in the solution. If we were to evaporate all the water out, we would get magnesium chloride salt back. But right now, it's still aqueous. And this solution is neutral because the number of hydronium ions and hydroxide ions are even. Even if 2 of these water molecules collided, what would result would be a hydronium and hydroxide ion, which would still keep this ratio equal, which would keep this solution neutral. Now what if we didn't balance this equation? Would the solution be acidic or basic or neutral? Let's try it. If we were to keep the ratio of hydrochloric acid and magnesium hydroxide as 1:1 instead of balancing our equation, we would still have this dissociating it into its ions. But there's just not enough hydrogen to join up with the hydroxide. So we'd still end up with one hydroxide left over, which would mean this solution ends up being basic. And we can see that from the equation. There are 2 hydroxide ions for 1 hydrogen ion. So we need this to be doubled in order for it to be a true neutralization reaction. Let's finish up with a couple practice problems. What is the pH when the ratio of hydronium ions to water is 1 to 1,000? We put our ratio as a fraction into scientific notation, and we get a pH of 3. Okay, here's a tricky one. What is the pH when the concentration of hydroxide ions is 1/100? I'll give you a clue. We have something called the pOH, which is exactly like pH, but with OH. And if we add the pOH and the pH, we should get 14. See if you can figure this out. So I can find my pOH really easily. Turns out to be 2. I subtract that from my total value of 14, and I get a pH of 12. So for this one, we're putting an acid, hydrofluoric acid, into water. What would the products be? I know that hydrogen atom is going to latch onto water and become a hydronium ion, which just leaves a fluoride ion left. What about if we put potassium hydroxide in water? Still going to have some water, but that potassium hydroxide is going to dissociate into its ions, potassium ion and hydroxide ion. What about when I put these two things together in solution? So this is a neutralization reaction because I have an acid and a base. So I'm going to get a salt in water, and the salt is going to be from this double displacement reaction. So I'll get potassium fluoride with water. Okay, last one. What does the ratio of this acid, sulfuric acid, to sodium hydroxide have to be for the products to be neutral? How many of these to how many of these for there to be neutral products? So we know we'd have water as one of our products in a neutral reaction. And then we would get a salt. To figure out our ratio, we need to balance this equation. There's 2 sodiums here, so I know I need to double this. That gives me sodium on each side. I have 1 sulfate ion in each side. I have 2 hydrogen, 1 oxygen, but then I have 4 hydrogen, 2 oxygen, so that's an easy fix. Balance my water. So for the answer, I have 1 acid for every 2 base in order for it to be neutral.